All right, so we've developed two formulas for columns, air columns. So our first one is for a closed-ended air column, and the other one is for an open-ended air column here, and a closed air column there. So a couple of examples, something that you're going to see in the homework. So an air column that's open at both ends. So remember that it is open at both ends because the mouthpiece is considered an open end. All right, so that's why it's open-ended at both ends, or that's why we consider it. So we know that the air column is open at both ends. It's 1.5 meters long. So we're going to just go through and decode this. So I know the length of the air column is 1.5 meters. A specific frequency is heard. So no information is there. If the air temperature is 20 degrees, so temperature is 20 degrees Celsius, what is the longest possible wavelength and its frequency to cause resonance? So we're looking for the longest possible wavelength. So wavelength is lambda. And we're also looking for our frequency, also an unknown. So there's two things we need to calculate here. So where does frequency come from? Well, it comes from our universal wave equation. So V equals F lambda. We're looking for frequency, so I'll rearrange the equation, and we get V over lambda. I need to know the velocity of sound in air. So from previous lessons, 332 plus 0.6 multiplied by 20 divided by wavelength. Well, I don't know the wavelength yet. So that means there must be another calculation in there. And when you're working through questions like this, it doesn't really matter. I can put this in here. It doesn't matter where you would have wrote it. If you have to find lambda, you have to find lambda. So what I'm going to do is I'm just going to mark, this is my attempt at frequency. So now I got to find lambda over here. So what am I dealing with here? Well, I know my L, so that's the only thing I do know. I know the formula for an open-ended air column is length equals n over 2 multiplied by lambda. We are looking for the longest possible wavelength. So longest possible wavelength, longest lambda occurs when n is small. How small can it be? Well, n will have to equal 1 because we have to have minimum one nodal point. So that tells me that L will equal 1/2 and, oops, sorry about that. We know what L is. It's 1.5, and we know n is 1/2. So we can find lambda here, multiply both sides by 2 to get rid of the fraction, and we end up with 3.0 meters is our lambda, and there is one of the answers we were searching for. Can now bring that over to the other side here and finish off the natural frequency. And once I put that through the calculator, I get about, let's call it 115 hertz. So now I have both answers to the question. So you're just playing with the formulas that are associated there. So therefore, wavelength is 3 meters, and frequency is 115. So again, it goes back to grade 11 is a lot of decoding, giving you the basics of the grounding. So when you enter into the grade 12 course, we can expand it out to a little bit more of a thought process. Okay, final example then, closed air column this time. Resonates at 2 consecutive lengths. So what they're doing is they're telling us the length of one resonant length and then the length of the other one. So they're telling us 2 lengths. So the first length is at 94 centimeters, and the second length is at 156. We know we're dealing with a closed air column, so I'm just going to write up the formula L equals, and in this case you have the 2n minus 1 over 4 multiplied by lambda, just as a reminder. Air temperature is 20 degrees again, so we can look back to the previous example. because that will tell me the velocity of air. We go back to the previous page here. Oh, I didn't actually calculate it out, but it's going to be 332 plus 0.6 times 20 meters per second. We want to determine the resonant frequency of the air column. So we are going to look for our frequency. We're looking for F. All right, so again, we only have the one formula that involves F, and that is our universal wave equation. And once again, I'm going to rearrange it. So I have the velocity in air divided by wavelength. So I'm going to have to find wavelength again, because I already know, similar to the last question, 332 plus 0.6 times 20 is my V. Now, wavelength is a little bit more challenging this time, because L1 and L2, I don't know what harmonic they are, how many nodal points are involved there. Okay, it's not given information. So what does that mean? Well, if we go back to our chart here, it does tell us we have two consecutive wavelengths, or natural resonant lengths. So that means that it could be this one and this one. Whoops, didn't really want that. It could be these two together, or it could be these two. We don't know. It could be way down at the 5th and 6th. What we do know is that when you have two consecutive harmonics, that the relationship is half lambda. So I know that the difference between L1 and L2 is going to be half lambda. And that's where I'm going to start here. So I'm going to say delta L, so the difference in the two wavelengths is equal to 1/2 lambda. And that is from our chart. So here's another formula you probably want to add to your cheat sheet or your study sheet. So that tells me that L2 minus L1 is going to be half lambda. So now I have all the information I really do need here. I know that 156 take away the 94 is 1/2 lambda. Doing the calculation, I know that 0.62 is equal to half lambda. Multiply both sides by 2. I find that lambda is 1.24 meters. So I was able to find lambda, and I'm just using the pattern that we developed in the previous chart, which now allows me to put lambda in to determine the frequency. And when we go through and calculate it, we get 277.4 hertz. So therefore, frequency is 277.4 hertz. All right, so you're just playing around with existing formulas. Remember, the relationship that we developed in the chart is what you'd call fair game. So that's good to make sure you add on or make sure you note on the particular study sheet. There's the homework for this particular section. If you have any questions in class about the note, let me know, and I will help you out.